Let us start by doing this. Let's make our title. All right, so we can talk about what it is we're doing today. So we are going to find the volume of cones with a fixed radius. So what I mean by that is we're going to make a bunch of different cones and we're going to keep the radius the same. We're not going to change the radius. But what we're going to do with each cone is we're going to change the height. And then we're going to see how that changing height affects the volume of the cone. And then we're going to create a function table and then graph it so we can explain what kind of function it is. Is it a linear function? Is it nonlinear? Is it exponential? Like what kind of function is it? Okay. So first things first, let's go ahead and create our first cone. So let's call this cone number 1. All right. We're going to create a cone with a radius of, let's see, today we are going to keep using 3 for the radius. Okay. So what we're going to do is we're going to start by creating a radius. All right. So let's do that first. And then I want you to make a line on your paper that is 3 units, okay? So we're going to go from here to 1, 2, 3, 3 units, okay? Now remember, there's really 3 units on the opposite side of that point. This point is the center of our circle, okay? So let's not forget that. Now, what I want to do next is create the height. All right, and let's start with a height of, let's say, 1, 2, 3. Let's start with a height of 3 today. All right, because a height of 1 would be so short, it would be kind of hard to kind of draw the cone if the height was too short. And then I want you to make the circle that goes around this radius. All right, so we draw our circle, and remember we're doing 3 on the other side as well. All right, so it should look something like that. And then you have to make the lateral surface of your cone. I could do better. Let me see if I can get it to. All right, so it should look something like that. All right, guys. So let's make a statement on, not a statement, but let's just record what our dimensions are. I want you to, somewhere next to this cone, just say your radius is equal to 3, and also say the height is equal to 3. All right, now let's do this next. After you get number 1, we're going to create our second. We're going to create our second cone. And we're going to have the same circular surface. So basically what I want you to do is recreate the top surface, okay? So the top surface is going to look the same. All right, we're going to make a circle with a radius of 3. However, what we're going to do with that is we are going to change the height this time, okay? So this time, instead of a height of 3, we're going to go to a height of 4. So from the center, we go down 1, 2, 3, and 4. So it's just a little bit taller than the previous cone. And then, of course, you would make your sides of the cone. And this cone has a radius of 3 and a height of 3. I'm sorry, a height of 4. Radius of 3 and a height of 4. All right, let's go to cone number 3. All right, so once again, we are creating a circle with a radius of 3. The radius is fixed. Okay, we're not changing the radius at all. All right, so the top surface remains the same. So every time you create these cones today, you are trying to make everything look the same for the top surface there. Okay, you're trying to copy it every time. And notice from the first cone to the second cone that it basically gets deeper each time. Okay, and now we're going to create a height of 5. We are going to form the sides of our cone. And record the dimensions, radius of 3 and a height equal to 5. Let's go on to number 4. Number 4. All right. So once again, on your paper, your top surface should look the same as all of the other cones. So we are going to basically copy our circular surface. All right, and create a height of 6. So we are going to have this go down 1, 2, 3, 4, 5, 6. There we go. And we're going to make our lateral surface. By the way, for those of you who don't know what lateral means, it just means side. That's what lateral means. Okay. And we have a radius equal to 3 once again, and a height equal to 6. And now what we're going to do is we're going to find the volume of these cones. So let's go ahead and do that. All right, so let's go to number 1 here, and I want you to write. Now, only with the first one, we're going to actually write the entire equation. And then with the other ones, we're going to plug in the numbers straight away. So for number 1, I want you to state that V for volume is equal to pi times the radius length squared times the height divided by 3. And just as a reminder, the numerator here is actually the volume formula for a cylinder. But because the cylinder would occupy 1/3 of, because the cone would occupy 1/3 of the cylinder space, we divide by 3. So this is the formula that will give us the volume of a cone. Okay, now let's go ahead and plug in all the appropriate values. So we have V for volume is equal to, we're going to substitute pi with 3.14 like we did yesterday. And we're going to plug in a radius of 3. Now today, our radius is not going to change, okay? So every time we solve today, we are plugging 3 in for the radius. So in a way, we're treating it like a constant today. It's not going to change. But the thing that is changing today, our variable is going to be height. And the thing that's changing each time, we are considering our input. We keep inputting different heights into our equation. And this input for the first one is 3. And we have to divide all of this by 3. Okay? Now, let's simplify this just a little bit. Now notice that we have a 3 on the top and a 3 on the bottom, and we should know that 3 divided by 3 is 1, so that makes our lives a little bit easier. We can simplify by changing these both to 1s. Okay, so this is really a 1 and this is a 1. All right, and what we're going to do next is we are going to say that volume is equal to 3.14 times 3 to the second power, which is 9. And whatever that is going to be our answer. So we're going to go ahead and multiply those two numbers together. So that ends up giving us, let's see here, 28.26 square, I'm sorry, not square, but cubic units. Okay, cubic units. All right, number 2. Now, this time we're not going to restate our entire equation because we have it written right here. We're just going to plug our values in straight away. So let us say that volume, which is our output, that's what we're looking for, is equal to 3.14 times the radius is still 3, and we are squaring the radius, okay? But this time our height is 4. And we have to divide all of this by 3, okay? All of this by 3. Now, with the previous problem, the height was 3, so we were able to cancel this number with this number, but we can't cancel the 4 with the 3 because they don't have any common factors that will reduce these numbers, all right? But here's what we can do. All right, here's what we can do. Let's go to the next step and do this. Volume E equals 3.14 and let's change 3 squared into 9 times 4 over 3. Now, because 9 and 3 have a common factor, we can use a little bit of cancellation here. But they don't turn both into 1s because they would have to be the same number for that to happen. What this essentially is 9 divided by 3. And 9 divided by 3 is 3. So you would actually change this 9 into a 3, and you would change this 3 into a 1. Okay? Because 3 is the biggest factor that can be divided equally into 3 and 9, I just mentally divided 3 into both numbers. So like 9 divided by 3 is 3, and 3 divided by 3 is 1. Or more simply put, because you can equally divide 9 by 3, 9 divided by 3 is 3, I just wrote it as 3 over 1. And 3 over 1 is the same thing as 3. Okay? All right, so let us finish by solving this. Volume equals, we have to multiply 3.14 times 3 times 4. And we can go in any order we wish. We could do 3.14 first times 3, and then take that and multiply it by 4. But I think it's easier to do 3 times 4 first, okay, which is 12. And then we can multiply 12 by 3.14. So when you multiply this all together, you get 37 and 68 cubic units. All right, let's go ahead and calculate the volume for cone number 3. So we're going to start with V for volume is equal to 3.14 times a radius of 3. So we have to square our radius. We always square our radius when finding the volume of a cone. And we're going to multiply by a height of 5 this time. And we are going to divide that by 3. There we go. All right, so on the second line here, we're going to simplify a bit. All right, we are going to say that 3.14 times 3 squared is 9 times 5 divided by 3 is the volume of our cone. So all of this is the volume of our cone, but we haven't gotten it to one value yet. All right. Now, once again, we can cancel out the 9 and the 3. So let's go ahead and do that. So the 9 is going to become a 3, and the 3 is going to become a 1. Now, if you were so inclined and you weren't good at canceling, you could just take your calculator and had multiplied all the numbers straight across, and then taken that answer and just divide by 3, and that's going to give you the same answer. Because I still have some students who get a little bit confused by the cancellation piece, okay? So it's not necessary that you cancel. I just think it makes the work a little bit easier. So I'm just in the habit of using cancellation. All right, let's go ahead and do this. We are going to take 3.14 and multiply it by 3 and 5. So I'm going to do 3 times 5 first, which is 15. So basically, I'm going to take 3.14 and I'm going to multiply it by 15. And that gives us a volume of 47 and 1/10 cubic units. All right, for our last cone, we are going to take 3.14 and we're going to multiply that by the radius squared, which is still 3. And we're going to plug in a height of 6 this time. And we're going to divide everything by 3 as we always do with a cone. Now we are going to take 6 and 3 and cancel straight away. So if we took 6 and divided it by 3, that works out perfectly. That's 2. So we can say 6 over 3 is equal to 2 over 1. All right. Now we can proceed to the next step, which is volume equals 3.14 times 9 times 2. Okay. Now we have 2 times 9 at the end, so we can just say that that's 18. So what we're going to do is we're going to take 3.14 and we're going to multiply that by 18. And that gives us a volume of 56 and 52 hundredths cubic units. All right, guys. So what we have to do now is we have to make our function table. Okay, so let's go ahead and do that. Now, remember with a function table, the left column is our input, which is the x, and the right-hand side is our output, which is the y. All right. So the thing that we keep inputting into our equation, the thing that keeps changing in this situation is our height. So what I want you to do is label this column your height. And that is our input. And I want you to label the output volume. All right, that is what we're looking for. And remember, with a function, our output is always dependent upon what we're putting into the function, okay? So what we're going to do first is we're going to start by putting a 0 here for height, okay? Even though we didn't draw that, it's impossible to draw a cylinder with a height of 0. I mean, I guess you could say it's just a flat circle, and that would mean it could hold nothing, all right? So it would just be a flat disk without the ability to actually hold something. So if you had a cylinder with a height of 0, there would be no volume, okay? Now, when we plugged 1 into our equation, a height of 1, we didn't even do 1 today, my bad. The first height that we used today was 3. So let's put 3 in for the height, okay? And we ended up getting a volume of 28.26, okay? And our next input was 4 for a height, and that ended up giving us an output of 37.68. And our next height was 5, and that gave us a volume of 47.1. And the last one we did was an input of 6 that gave us a volume of 56.52. Now, what we basically have here are points that can be graphed, and we can visually see what kind of relationship we are dealing with here. We can see if it's like linear or nonlinear. And what's important is when you're graphing, the axes that you set up have to be accurate, all right? So like if the marks that you make on your number lines are off, your points will be off, and the shape that is formed by connecting those points will be off. So it is important that we are precise when constructing our coordinate plane. So let us go ahead and do that. Now, when we're looking at the height here, the highest number we had was 6. All right, so we just have to make sure to go up to at least 6. All right, so here's what I'm going to do for constructing my x-axis today. I'm going to start here, which is 0, and I want to go to 6, but I am going to count each square as half a unit. So it's going to take me 2 of them to make 1. So I'm going to call this 1, 2, 3, 4, 5, and 6. Okay. And this is going to be 0. This is going to be 1, 2, 3, 4, 5, and 6. And I'm going to label this axis X, and I'm going to label it cone height. All right, now remember, all of our cones have a fixed radius, all right? So the only way we can explore how one of the variables can affect the outcome, all right, or the output, in this case volume, is by constraining or keeping one of the other variables exactly the same. In this case, we kept the radius the same, and that allows us to explore how the height itself would change the volume, okay? All right, now let's construct our y-axis. So for the y-axis, we have to at least go up to a little bit over 50. In fact, we have to make sure we can graph 56.52, so maybe we just go up to 60. All right, so let's see what we can do here. If we count it by fives, that would be 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. And I ran out of room a little bit, so what I'm going to do is I'm going to actually just take all of my work and shift it down just a little bit to accommodate what we need to do. All right, so now what we can do is make our y-axis. And now I can actually go ahead and count by fives. Let me move this over just a tad. There we go. And I'm going to call this 0, starting at 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. All right, now this number line can accommodate all of the values I have in my output column or y column. All right, now we have to label this axis the y-axis. So I would just put a y somewhere in that general area and label it volume. Okay, so this is the volume. All right, it was a little bit hard to write sideways there. All right, this U here looks more like a V. Let me see if I can. All right, good enough. Now let us go ahead and plot our points and see what kind of relationship we have. So we're going to start at the origin, 0, 0, right here. And then we're going to go to 3 and a little bit over 28. So we're going to go all the way to 3 here. Now don't use 1 here. All right. You might just accidentally think we're going 1 at a time, but we're not here. We didn't use a height of 1, nor did we use a height of 2. So let's go to 3 and go up to a little bit before 30. So make your point maybe approximately in this general area. And then we're going to do that for 4, 37.6. So that's almost 38. So we're going to go to 4 and about 38, which would be maybe about right here. All right. And then we're going to graph 5, 47. This is so close to 47. I'm just going to consider it 47 for now. So 5 and 47, which would be about right. Well, this is 45. So 47 would be about right here. And the last one is 6, 56 and a half about. Okay, so a little bit over 55. So we're going to go to 6 for the height. And that's going to make a volume of a little bit over 55. So maybe about right here. Okay. All right, now let's go ahead and do this. Let us go ahead and connect these points and see what happens here. Now, if you take a look, we have a linear relationship. All right, so we would say that the relationship of volume and cone height when the radius is fixed is a linear relationship. All right, that means we could come up with some sort of y equals mx plus b equation with this right here. Now, one thing we should also notice here is we didn't look at a volume of 1 and 2, but now we actually have a graph and we can see about what the volume is. So like if we look at 1 down here for the height and go straight up and put a point, it looks like it's right below 10. So it looks like our volume is around like 9 cubic units. If we had a height of 2 and went up, then that looks like it's a little bit before 20, like maybe around 18, maybe about 19 or something like that. All right. So we could actually use different heights down here to see what our volume would be. But remember, we have a fixed radius of 3. All right. So we're going to end this by making a function statement. Okay. We're going to say that volume is a linear function of cone height when the radius is fixed, meaning not changing each time. We kept the radius length 3 in this case. All right, so we definitely have a linear relationship or a linear function here. Hey, I just want to say thanks for checking out this math tutorial. Please don't forget to hit that subscription button and activate notifications so you can be informed as I upload new math tutorials that just might help you with your math homework. Until next time, this is Shane Masonette with Masonette Math.